class start on.
Good morning, good evening, everyone.
Saram, sir.
Saram,
Saram, sir.
Sairam.
Saram sir.
Okay, hi, Saram. Saram. Sumant, over to you. I'll just stop the share because some more people are there. I'll admit them and then give the hosting to you, Sumant.
Okay, fine.
Suman, maybe you can start off. We'll just have 3 more participants will join.
Okay, fine. I still do not have the permissions to share my screen.
One moment. Try now, Suman. Yeah, perfect.
Yeah, perfect. All right. Um, Good morning, class, and good evening to the Indian participants. Today, we'll be moving on to our uh, to the topic of interfacing Arduino with Python. In our last class, I um, I explained you the concept of machine-to-machine communication, and as well as ask you to install a few softwares and create a few accounts. The first software that I have asked you to install was the Arduino IDE, and the second was to create an account in ThinkSpeak. So in our last class, we had also seen the definition of Internet of Things, what Internet of Things was, and how uh, what is the process of that's happening in Internet of Things. We have seen that a sensor was interfaced to a non-living thing, and this sensor was able to gather data. The data gathered was again was had to be sent to some other place, um, and we had seen that this process was called as the Internet of Things, and machine-to-machine communication was used in sending data from our local environment and from our physical thing to some other place. We had also seen uh, um, on what a sensor is and uh, what is the significance of a sensor. We had discussed that a sensor essentially senses something physical, and it reads out the change, and the change is again taken as a change in voltage or current, and that was used to define um, uh, how much amount that quantity has changed. We had seen the example of a temperature sensor by taking the example of a thermometer first, and we had seen that when the mercury level was rising, the physical change brought in the change in the length of the mercury, and the change in the length of mercury uh, was used to measure the change in the temperature. Similarly, we had seen that different temperature sensors in the market, they also worked in a similar way. So a change in the temperature resulted in a change in the electrical properties of the sensor, and that's how the sensor was able to detect change in temperatures. So today we will be discussing about a very important platform and an IDE called as Arduino. This is very much helpful for uh, kids. It's also useful for developers. It's also useful for engineers who want to do quick or rapid prototyping by interfacing different sensors to the Arduino board and collecting the values from the sensors. So it is very easy uh, by doing it on an Arduino board. Um, but whereas people in the actual engineers, they use something far more sophisticated than the Arduino boards. But um, for beginners, it's important that how an Arduino works, because you will get a basic idea of how to interface sensors, and then we'll be trying to interface our Arduino along with uh, our Python programming language. We'll see how we can integrate Python and Arduino. Okay, so let's get started by first defining what an Arduino is. Okay, so let me
Sir,
let me start my video.
should we have the Arduino board near us when we're doing this?
Uh, Not now, but I'll let you know when you will be requiring it.
Okay, thank you.
Maybe in half an hour, maybe will be required.
Okay.
Okay, so this board that we see over here is an Arduino board. Some of you might be having it. Uh, some of you might have already received it at your homes, and some of you might have placed an order. Uh, but don't worry, I'll be just giving you basics of this board. Even if you do not have a board at hand today, it's okay. You can manage the session. I'll be just giving you uh, an in-depth or just an overview of uh, how to use this board, and how do we program, or the basics of this board. And then once you get these boards delivered to you, we can start our programming sessions, and we'll try to finish our projects. Okay, so this board that you see, uh, or the physical board that you see, is called as an Arduino. Okay, and there is one chip attached to the board. Okay, so this is the chip that is attached to the board, and this chip is called as a microcontroller. Okay, this chip is called as a microcontroller. Now, um, you might have used something like an Intel processor. Um, okay, so uh, a so that the Intel i5 or i7, etc., they are called as microprocessors. and this is called as a microcontroller. Okay, so basically they are almost uh, s- like they have a similar functionality. Only thing is this thing does not require any operating system to work, but whereas a microprocessor it generally has some operating system like Windows or Linux supporting it. Okay, so this board itself is called as an Arduino board, and I have asked you to download a software called as the Arduino, and that software uh, something similar. Um, just a minute. Okay, so this software over here, um, what you see is called as the Arduino software, and we use this software in order to create programs and dump into our Arduino boards. Okay, so you're getting it right. So I just want all of you to first open this software upon your computer screens, and as soon as you open, tell me what you guys are seeing.
Sir, I see the exact same thing as you.
Yeah.
Yep. So you might be uh, as soon as you open it, you'll be seeing uh, two blocks or like this over here called as void setup and void loop. Okay, so we'll have to write code inside these things in order to dump into our Arduino microcontrollers or Arduino boards. Um, so in today's class, we'll discuss the basics of how we use this one, the software, and develop code upon this software. Now, in our previous classes, we had learned a few basics of the software, like we have declared strings, we had declared integer numbers, we had declared floating point numbers, we have used for loops, we have used while loops, and so on and so forth. So all these concepts are pretty much the same in Arduino as well. If you know how to do these things in Python, then it will be a cakewalk for you to use Arduino as well, because the programming syntax or um, uh, like how you code is almost similar to your Python, bearing a few differences here and there. I will tell you the differences whenever they come, but mostly it is almost similar. Okay, so we will see what an Arduino is. Now you might be confused on whether our Arduino is actually a hardware or some integrated development environment like this. Like, is it a software? Is it a compiler, or is it a programming language? Now, Arduino is actually all of these. It is hardware, it is this software, and it is a compiler, and as well as it's a programming language. So Arduino is all of these. Like, we call the setup of hardware plus IDE plus compiler plus the language all together, we call it as uh, 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 call them as Arduino. But the only thing is, when we are referring to a board like this, so when we are referring to a board like this, It is called as the Arduino hardware. When we are developing it on uh, this software, it is called as Arduino IDE. When we are compiling our source code, it's called as the Arduino compiler. And when we are writing it, writing the program, it's called as the Arduino language. Okay, so Arduino plus hardware is the Arduino hardware, Arduino IDE, Arduino compiler, Arduino language. Okay, we put Arduino in front of everything, and we call this combination, this entire combination as Arduino. Okay, now let's see a brief history of of how Arduino was developed, so that we understand the importance or the breakthroughs Arduino has made in electronics, or um, uh, or for the researchers and innovators like you people, like me, who would like to implement projects, mostly science projects. Okay, so here Arduino is an open source electronics company, okay, which has its own platform. Like this entire thing is called as the platform, based on easy to use hardware and software. So the hardware that we see, or the boards that we see, are the just a minute. And it says, okay, um, so now let us see what the term open source means. Okay, so now we have two types of things. One is called as the closed source, and the other is called as the open source. Now, open source is something which we can get for free. Okay, there are some softwares that you can use for free, and there are some softwares for which you will have to pay some money in order to use it. Now, can you tell me some softwares for which you pay money and use?
Microsoft products.
Yes, correct. So for Microsoft products, we generally,
Windows.
yeah, Windows is also a Microsoft product. Um, yeah, it could be some antivirus software. It could be Windows. It could be the Microsoft products like Microsoft Office, Word, Excel, etc. All these are something which we pay money in order to use. Now there are something called as open source as well, which means you do not need to pay any money in order to use them. They are free. You can download them from the internet, and you can install them and you can use them. There's nobody to stop you when it is an open source. Now, an example for an open source software is Linux. The operating system Linux, it is an open source operating system. It is free to use. You do not need any license for it. Now, similarly, you might have used VLC media player. That is also an open source software. Okay, so something for which we do not need to pay any money is called as open source. and Arduino is one such open source platform. So this is for Arduino is for electronics, and Linux or VLC are software products. So they are open source softwares. Arduino is an open source hardware or electronics. Okay.
Sir, I have a question. Then
Yep.
where do these open source softwares make money? Like
And
Arduino?
okay. So open source softwares, they generally uh, do not aim to make money. They generally are community based, and if you are an open source contributor, then you can develop software and you can release it to the public, because many of us uh, are not that rich enough, or we cannot afford that thing. So what people are doing these days are, they want to contribute to the society, something like social work. They want to build some softwares, and they are releasing them on public domain. So that is how the open source community works. But yes, there are some models in which the open source softwares also make money, like they accept donations from their users. Like if you like the product, then they ask you to donate something. So that is how generally these things make money. Now when you take Arduino for example, uh, while you are downloading the software, uh, it might have asked you to either donate something to them, or just download it right away. Have you observed it?
Yes, sir.
So they ask for COVID-19 relief funds also.
No, no, no. Like
I got the message, sir. Like when I was downloading, like I just got it.
yep. So at some times they might ask you. For example, let us see. When you're downloading the software, suppose say Windows installer or a Linux 64-bit. When I hit it, it will ask to contribute to the Arduino software. Consider supporting Arduino software, something like this. Like it will ask you to just contribute to them, or you can have an option called as just download. So it's up to you when you want to just download it for free. You are welcome to do so. But if you feel that these guys are genuinely doing some good work, and uh, you can spare some $5, then you can pay them the amount as well. So that is how the open source softwares people they generally survive. But mostly they depend upon uh, the open source community to contribute to them. Like you can develop some code, and you can just uh, give it to the people. So what you're doing is you're working for free. So since you're working for free, uh, um, the like your work itself is worth something, right? So so that is how these most of these companies are operating. Okay, so Arduino is also as a hardware that is that what we have seen. Uh, this the Arduino company, it comes up with various boards. Now the board that we are purchasing or we are using is called as the Arduino Uno, UNO. Now there are multiple versions of Arduino in the market. Um, which you are open to choose from. But we have chosen Uno because it's the basic one, and also uh, it is sufficient enough for us to use this thing. Now there are much more advanced boards out in the market as well, but we have chosen the basic one to start with. Okay, now they have boards of various companies like AVR is one microcontroller company. ARM is one microcontroller company, and there are boards of various other companies as well. So they do release boards, and uh, the Arduino. What they have done is they do sell some hardware as well, so that is how they are making money out of this thing. But they have released their entire schematics online, so you are ready to replicate their hardware as well. So they have their schematics available online. So all you need to do is you can download their hardware schematics, and you can buy various components from the market, and you can assemble this whole board all by yourself. Nobody will stop you because it is open source. But whereas if it is a closed source or proprietary to a company, then you might be asked that like if it is patented or copyrighted, then you might have some troubles that you might be facing when you are using such something. But Arduino being open source,
Sir,
you're free to do it. Yeah,
sir, I have a question.
yeah,
Um, if you're using the Arduino IDE, right? How
yeah.
do you transfer it onto your Arduino board?
Yeah, I'll. It's all part of today's lecture. I'll tell you.
Okay, thank you.
Fine. So, Arduino is a software as well, like the Arduino IDE. It comes with a few compilers packaged into it. Now, in our first class, uh, I discussed the concept of a compiler and uh, an interpreter. Now, what is Python? Is it a compiler, or does it use an interpreter?
It's a compiler.
No.
Compiler.
Python uses an interpreter. It's an interpreted programming language. We had seen that Python was interpreted, and that's why we could right away execute a program. But whereas Arduino, it's a compiler-based programming language, and you will have to compile the code first, and then only you will be able to use it. This is one difference that we had seen in our first class, and this discussion came up uh, a few days earlier as well. So just remember that Python is interpreted, Arduino is compiled. Okay. Now you will be getting much more clarity when I compile some code on Arduino, and you will understand the flow of working using Arduino, and you will understand the basic difference between a compiler and an interpreter at that time. Okay, so this is how an Arduino IDE will look like for you. Okay, it basically has uh, two pieces of or two blocks already written out for you. One is called as the setup loop or void setup, and the second is called as void loop. Okay, now this is the basic structure that you might be seeing over here. So void setup and void loop. Now let us see what we can put inside setup and what we must put inside loop. Okay, so inside the setup function, just a minute. Okay, um, so inside the setup function, the main purpose of having a setup is that a sketch it will start from setup. So now we can initialize some variables. Now we had seen in Python that we can create variables of type integer, of type floating point, etc. So here also we can create a few variables, and you will have to create variables inside setup only. Okay. Now the same concept of local variables and global variables, as we had seen in Python, they will also be used in Arduino. Now, can anyone of you refresh me the concept of a local variable and a global variable?
A local variable is a local variable is inside a certain loop, and a global variable is outside those loops. And when you're trying to print something, right, the global variable always overrides the local variable.
Yes, correct. Is is Tanvi in the meeting? Okay.
Sir, she's not in the meeting.
Okay, I've asked, like she pinged me that she wants to join, but I saw the message just. I've asked her to join back. Okay, fine. So a local variable is something um, which will be used inside a function itself. Like here, void setup is a function. So whatever we define inside a function, uh, that particular variable will be uh, um, can be used inside that function only. Okay, but whereas a global variable is something that can be used outside my function as well. Okay, so I'll have to define it outside my function so as to use it in any of my functions. So that's one concept of local and global variables that we have seen. So that is something that we can do. We can initialize a few variables. Okay, we'll see on how we can initialize variables. But just remember that inside setup, we do all the setup of initializing the variables, set our pins to different modes. Now you might have observed that our microcontroller Arduino, like what you see over here, it has a few pins. Okay, it has a few pins like these. Now what we can do is inside setup we can set the mode for these pins. Like either we can set these pins as an input pin or as an output pin. Okay, input pin means we will be taking something as an input from using these pins, and output pin means from this board we will be sending some voltage as an output. Okay, and for input we will be accepting some voltages uh, to this board. Okay, so that's what we mean by the pin modes, and we can start using a few libraries, etc. I will tell you what libraries are. Okay, uh, and this setup function will run only once. Like when you start your board, this setup function, it will work only once. Okay, after each power. But whereas when you come to the loop, this is an infinite loop. Okay, now we had seen in Python that we have something called as we can use something called as infinite loops. Now how do we do that in Python? How do we create infinite loops? We can create an infinite loop using a while. Okay, now how did we do that in Python? While true. Yes, so when we use something like while true or while one, what it meant? It meant that um, whatever be my condition, uh, since I am doing while true, it will go on continuously execute it without any stopping. So that is an infinite loop. Okay, so when I do something like while true or while true, it means it is an infinite loop, right? In Python we had done it, but here in Python we had done it with while true statement, but here by default we are getting a infinite loop. Okay, and the purpose why we are getting an infinite loop, we want an infinite loop is when we are sensing something, we want to sense it continuously, right? We do not want to sense something and then stop the execution. We do not want something like that. We want to continuously sense the temperature of something uh, until it is on, right? So since we want something like that to happen, Arduino gives us a provision using the while loop. Okay, so the purpose of having a loop function is that after creating a setup, like after this thing it executes, it moves on to the loop function, and inside the loop it uh, your main logic is implemented in loop. So it is continuously repeated multiple times. Okay, so suppose say we want to interface something, and we want something to happen for some time. So or we want to happen we want that thing to happen continuously. We put it inside void loop. Okay, so that is the basic functionality of having a void setup and a void loop. Now I will try to teach you one basic program, and you will be understanding uh, the concept of uh, Arduino better. So first thing, what do we need to do in our void setup? We had seen that we can use it to initialize variables, pin modes, and start of libraries. Now uh, uh, let us see how we can initialize something. Okay, suppose say I want to create an integer. Okay, I can create it in this way. Okay, int I. So I can create an integer and I can initialize some value to it. Similarly, I can create a float number in this way. Okay, now in Python, we do not need to specify whether it is an integer or a floating point number. We can directly assign it right away. But in Arduino, you will have to declare what type of variable it is first, and then assign it to some value. Okay, and you need to terminate your statement with a semicolon. Okay, so Python and Arduino has some differences, and the first difference is that when you are defining variables, you will have to declare them first inside Arduino, and you have to end your all statements with a semicolon like this. Okay, so that is how we initialize some variables. Now we can initialize our pin modes as well. Okay, so we can initialize our pin mode using the keyword pin mode function. Okay, so this is how we yeah, initialize something. Oh, I have an example for you instead of writing that thing. Okay, so okay, fine. Let us type, and then we will be able to. Okay, so here um, there is something called as a built-in LED. Okay, now I can initialize it to be an output pin. Okay, now I have a built-in LED pin over here. Let me switch on my video. Okay, so you are seeing it, right? So here I have some light like thing over here. So that is my LED built-in. Okay, so now I am setting my LED built-in as an output, which means I want this light bulb over my board to glow as an output. Okay, so this is how I can initialize my pins. Now I can set some, like I have different pins over here. Suppose say I have a, pin 2, pin 1, pin 2, pin 3. So I have different pins over here. Okay, so I and each of these pins has some name in front of it. So the first one is called as pin 0, pin 1, pin 2, etc. When you have the board in front of you, you will be able to visualize it better. So once you get your boards delivered to you, you can see that there are a few letters written over here, or a few numbers written over here. Those will be your pin names. Okay, so you can write uh, pin mode as pin number and followed by whether it is an input or an output. Okay, now what I have done is I have declared this one pin as named LED built-in, and I have declared it as an output. Okay, so I can declare it as an input as well. Okay, so if I want it to be an input, I can declare it as an input. If I want it to be an output, I can declare it as an output. Now I'm writing a program so that I can glow that particular bulb Now when I want to glow something, I'll have to give some electricity to it. Do everyone agree to it or not?
Yes, sir.
When I want to glow a bulb, I'll have to provide some electricity to it. When I want to switch on a
Yes.
fan,
Yes, sir.
I'll have to
Yes.
provide electricity to it. So when I'm providing electricity to something, I'll have to give it from a particular unit to my thing of choice. Now, when I'm glowing my when I want my fan to rotate, what I'm doing, I'm switching on my board from my panel. So I'm turning on one switch, which means I am providing it electricity. So that thing I'm providing it as an output to the fan, right? So similarly, when I want to glow some bulbs over here or some LEDs over here, what I have to do is I have to provide some electricity. That is why I'm setting it as an output. Okay. Now what we can do is once we had set up the or once we have declared everything in our setup loop, we'll have to move inside our void loop. Okay. Now here, what we can do is we can use some functions to define our main logic over here. Okay. So here the initialization is done. After the initialization, what we want to repeat continuously, we'll have to write it over here. Suppose say I want to glow my LED. Now I have declared it as an output, but in order to glow it, I'll have to use the function digital write. Okay, there is something called as digital and there is something called as analog. Okay, analog is something continuous in nature, but whereas digital is not continuous in nature. But for now, just remember that Arduino has some digital pins and some analog pins, and our LEDs, they generally come under as digital units. Okay.
So, sir,
Yep.
how do we identify what is a digital write and what's an analog write?
It depends upon the sensor that we want to interface. Okay.
Okay, sir.
So there are some digital ICs, there are some digital sensors, and there are some analog sensors. And now, when you buy something, he will specify it to you whether it is an analog thing or whether it is a digital thing. And also, when I'm teaching you, I will tell you the difference on how we can identify whether the sensor that we are using, whether it is an analog or a digital. It is very simple. After all of you get your Arduino boards and all of you have your sensors in place, uh, like when we are implementing projects, you yourself can distinguish between what is an analog and what is a digital. But for now, I want you to know that there are something called as analog and there are something called as digital. Okay. Okay. So our LED is something digital. Now I have declared my LED built-in as an output. Okay. So I want to write my LED built-in, and I have two options. Either I can write a high or a low. Okay. Now we know that in digital, our computer is a digital device, is something which we have been learning. Now, when we call something digital, we 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 mean that it will understand either a 1 or a 0. Am I correct? We had also seen that our numbers in order to be stored upon our hard disk, uh, they were uh, they were converted into a series of ones and zeros, and there we had seen that and we had called them our digital data, and they were in a sequence of ones and zeros. So
Wait, so digital just means that it's like the thing we learned on the first class?
yes, 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 correct. Okay, so we had in that thing that case we had seen that one means the switch was on and zero means the switch was off. If you can refer to the first class of us of what we had, there we had seen a few figures like a few switches were there, a few switches were on, a few switches were off. So the on switches were represented by 1 and the off switches were represented by 0. Yes. So in order to write something, uh, uh, or in order to call something as on, I'll have to put it as 1. And in order to put something as off, I can put it as 0. Okay. Similarly, I can uh, do this. Like I'll call my 1 as high and 0 as low. Fair enough. I will call 1 as high and 0 as low
Okay,
because
sir.
1 is higher than 0, right? So what I'm doing over here is I am considering if I want to make something on, I am giving a high to it, and when I want to turn off something, I can give it a low. Okay. Now in Arduino, you can save something. Okay, let me save it. In Arduino, you can also have comment lines. Okay, in Python, how do you comment something?
Hashtag. You
With
use hashtag.
yes, we use
Sir, even quotation.
yep. We used hash, or we use the three triple quotes to comment some. In Arduino, you can use the double slash to write a comment. This is a comment. Now, comment is something which what we have called as non-executable uh, uh, content, and just for it is meant for us to um,
Refer back to it.
just identify that what that particular code is meaning. Okay, now I can comment. If I want to comment multiple lines of code, I can do it this way. Okay, I can start with a backslash and a star and end with a star backslash. Okay, so this is a multiple line comment and this is a single line comment. Okay, now this tells the concept of our Arduino on how we can uh, make some pins as high, some as low, and as well as set something as an output, declaring float, pin mode, setting outputs. Okay, so now once we are done writing code like this, what we'll have to do is we will have to hit on uh, the correct button over here. It's called as the verify button. Now what will this verify button do is it will compile the code for us. Okay, so that is why it is called as a compiler. Now in our first class we had seen that we had seen the example of a basic C program as well, which printed hello world to us. Now what we had done over there, we had compiled the code first and then only we were able to execute it. Okay, so similarly here also, in order to execute this code,